Okay, let's dive right into this. Welcome to today's explainer. We're tracking a literal beast today, a massive, migrating weather engine that completely dictates the lives of billions, and honestly, throws up some of the most intense, formidable challenges on Earth for anyone trying to fly through it. Yeah, we're talking about the global monsoon. Here's our flight plan for today. We'll start by defining the global monsoon, then track the ITCZ engine, check out West Africa and the Harmattan, head over to India and the Far East, look at tropical storms and typhoons, and wrap up with how to actually survive these monsoon aviation hazards.
All right, Section 1, defining the global monsoon. What are we actually dealing with here?
So, to avoid this beast, we've got to know its DNA, right? Now, historically, the word monsoon comes from an Arabic term that just means seasonal. For centuries, it described that totally predictable annual change in the Indian Ocean winds. Sailors and merchants literally rode those winds to build global trade. But look, from the cockpit of a modern jet, a monsoon is definitely not just a helpful breeze. In modern meteorology, the term has a highly specialized and, let's be real, incredibly dangerous meaning. We're talking about a massive, violent seasonal reversal of wind that whips up some absolutely terrifying flight conditions.
Moving to Section 2, tracking the ITCZ engine, the ultimate driver of all this weather.
Now, what's really interesting about this is figuring out what's actually pushing all that wind and water around the globe. The core mechanism driving this whole beast is the Intertropical Convergence Zone, or ITCZ. When the monsoon arrives, it's because the ITCZ has arrived. You can't just think of the ITCZ as a static line on a weather chart. It's a colossal, advancing belt of raw convective energy pushing up from the south. It is literally the invisible atmospheric engine driving the entire global monsoon system.
And the contrast across this zone? It's absolutely stark. It's basically a binary split in the atmosphere. On the northern side of the ITCZ, things are aggressively dry. You've got these parched, inflowing winds coming straight off the Sahara Desert with almost zero convective activity. But the second you cross over to the southern side, the whole environment violently flips. Trailing right behind that advancing ITCZ is this massive wide belt of torrential rain. It's wet, it's warm, it's insanely unstable. You're suddenly dealing with towering cumulus and cumulonimbus clouds. It's just a literal wall of weather stretching across the entire horizon.
Section 3, West Africa and the Harmattan. Let's track those double rains.
By tracking the migration of the ITCZ, we can predict exactly how things are going to unfold over West Africa chronologically. The system slowly creeps north, reaching about 15 degrees north, which puts it roughly over Dakar. Then, right around August, it retreats, following the sun back down south. Because this massive rain belt passes over the coast once on its way north and then hits it again on its way south in the autumn, you get the region's famous double rains. And these rains create some seriously dangerous choke points for pilots. Even wilder, high above all this surface chaos, easterly winds hitting immense jet speeds can actually spin up powerful West African tornadoes, dragging them way out toward the West Indies.
Now, when the southwest monsoon is active here, the air is just soaked, warm and highly unstable. But when the ITCZ shifts, the whole area gets completely taken over by the Harmattan. And this is a completely different kind of beast. The Harmattan is a dry, dusty northeast wind blowing straight off the Sahara. And we're not talking about a minor dust-up here. We're talking critical aviation hazards. The dust creates incredibly poor visibility inland. Visual flights become an absolute nightmare. Then, as that same dusty air picks up moisture over the jungle and moves offshore, it creates this incredibly thick sea fog over the cold Canaries Current between the Gambia and Sierra Leone. When visibility drops like that, you are totally reliant on your instruments, and your field planning has to be absolutely flawless.
All right, Section 4, India and the Far East. Extreme heat and massive rains. Over in India and the Far East, the whole engine is driven by extreme blistering heat. Here's how it plays out. Step 1, the sheer massive size of the Asian landmass heats up tremendously under the sun. This thermal effect basically turns the entire continent into a planetary-scale vacuum. So, Step 2, by April, all that intense heat pulls the ITZ racing northward, dragging it all the way up to 30 to 35 degrees north over China. Step 3, this huge low-pressure void yanks converging south and southwest winds straight in from the Indian Ocean and the Coral Sea. And finally, Step 4, all that warm, wet, unstable ocean air violently slams into the windward coasts and hills, just unleashing massive convective clouds and relentless rain. The sheer scale of this planetary vacuum is exactly why the flying hazards here are so intense. But before those rains actually show up, there's this brutal, seemingly endless waiting period. Between March and May, that cold northeast flow has totally stopped, but the wet southwest monsoon hasn't arrived yet. The result? India is left exceptionally, oppressively hot. The air is just stagnant and heavy. When the rains finally break, the relief is so monumental that it's deeply woven into Indian culture. It's literally life-giving. It transforms the landscape from baked, cracked earth into a thriving ecosystem almost overnight.
Section 5. Tropical Storms and Typhoons, the dangerous spin-offs of the ITCZ.
But listen, all that atmospheric energy doesn't just bring good news and rain. The movement of the ITCZ is the direct trigger for tropical revolving storms. Think of this massive convergence zone like a giant atmospheric spoon. As the ITCZ passes in and out of the Bay of Bengal, it's vigorously stirring the atmosphere, spinning up these colossal cyclones. The sheer volume of energy being thrown around by this migrating zone is staggering. It spins off secondary systems that are entirely lethal on their own.
Just look at the relentless timeline of hazards the system spits out across Asia all year long. In February, you've got the Kraken, this pervasive, stubborn low cloud and drizzle just hanging over Hong Kong. Fast forward to April, and the season for tropical revolving storms officially kicks off. Then from June straight through November, massive typhoons are battering Indochina and pushing aggressively toward Japan. And even after the main monsoon clears out heading north in July, by October, heavy rains are back, driven by those lingering tropical storms. The sky over this region is essentially a war zone for half the year. It just constantly throws curveballs at anyone trying to navigate it.
Which brings us to a really critical question. If you're operating an aircraft in this part of the world, dealing with a weather system this massive and chaotic, how do you actually stay safe? How do you fly when the sky is actively trying to bring you down?
That brings us to Section 6, Surviving Monsoon Aviation Hazards. Let's talk about navigating extreme danger.
Now we're focusing entirely on the intense dangers waiting up there and how aviation pros handle them. When you fly into the southwest monsoon, you're not just dealing with a little precipitation. You're flying into a gauntlet. The hazards? Blinding heavy rain, rapid structural icing at altitude, fast-moving clouds that obliterate your visibility in seconds, severe turbulence that tests the absolute structural limits of your airframe, violent localized gusts, hidden embedded storms, and severe lightning. Because of the insane energy we've been tracking, the towering cumulonimbus clouds, the massive thermal vacuums, you absolutely cannot just fly through it. Tactical avoidance is the only way. You have to know exactly where this seasonal weather engine is on any given day so you can route around it.
Our source material doesn't sugarcoat the stakes either. Meteorological knowledge isn't just some academic exercise for a pilot, it's quite literally their primary shield. Understanding exactly where the ITCZ is located, anticipating the thermal heating of Asia, tracking the weird behavior of the Harmattan, that's critical threat intelligence. Knowing the ITCZ's location lets flight crews plan routes that actively steer clear of the worst convection belts way before the engines even start. The crucial point is, avoidance isn't just a strategy here, it's the entire core of aviation safety. Many hazards to flying brought by SW Monsoons. It's a simple little sentence from our source, but man, it carries profound weight. The immense scale of the global monsoon is not something an aircraft can fight. You can't just punch through it with more engine power, and there is no way you're out-climbing those massive towering cumulonimbus clouds. You can't beat it. You can only outsmart it.
Which leaves us with something pretty fascinating to think about. If understanding the invisible migration of the ITCZ is a pilot's ultimate tool for surviving the monsoon, what other invisible global forces are quietly dictating the safety of our skies every single day? Keep your eyes on the clouds and never stop questioning what's driving them. Thanks so much for exploring this with me today.